Okay, how y'all doing? We're going to make a video here real quick because I know some of the folks at home do not have a textbook right now. So I'm going to try to help them out real quick by making a video. The textbook that I scanned was missing pages. So we're just going to run through this real quick, and I'm going to do the lesson real quick and just throw out there the highs and lows of everything that y'all need to know for this lesson. Today is October the 19th. It's Monday. And let's go ahead and get started. We started out by talking about microscopes and telescopes. And of course, if you look up at the night sky, you got to have a telescope because it makes the little bitty things that are in the nighttime sky much bigger, so that you can tell what it is you're looking at. If you've never looked at the moon through a telescope, it's a whole different looking thing when you look at it through a telescope. It's really, really cool to look at. Well, just the opposite. Microscopes do the exact same thing. They make things that are here on Earth that are little bitty, big, so that we can study them. And basically, 300 years ago, we did not have microscopes to look at. I got sweet tea because I got to have it. We didn't have microscopes 300 years ago to study the cellular world. And so this guy right here, his name is Robert Hooke. And yeah, he's kind of scary looking. Here, let's move me around a little bit here since I'm going to be showing a lot of pictures in this. Robert Hooke, he is kind of credited for discovering the microscope. And what he did was he looked at oak tree bark. And this is, if you don't know where cork comes from, well, it comes from the cork oak tree. And here you can see the bark, and here you can see the cork. It is part of the bark. And what happens is people will climb up these trees and they will strip the bark off of them. And if you leave a little bit of bark on there, a little bit of the cork on there, it will protect the tree and the tree won't die. So you get these really funky looking trees that have had looks like they've had their majority of their bark stripped off of them. Well, that's the reason why. Anyway, he took a piece of cork and he shaved it off, and he looked at it under the microscope. And when he looked at it under the microscope, he saw something that looked like this right here. And this is, of course, old dead cork cells from the bark. And of course, they're dead here. But when he looked at them, he thought, I bet you at one time there was living things inside of here. And of course, he was exactly correct. And he also stated that he thought that these things reminded him of honeycomb. And of course, honeycomb is where bees keep living things like their offspring are in honeycomb to protect them. Honeycomb is also what is used to protect the honey. So anyway, he decided to give these things the name cell. And the word cell comes from the Latin word cellula, which means small rooms. And they reminded him of the small rooms that monks lived in, these religious figures. And then we still got monks and monasteries around today. It reminded them of the rooms that they lived in on these monasteries. Their rooms were very small and very simple. And that's kind of what this reminded. It was a very plain, simple room. You may be more familiar with the term jail cell now. A jail cell is a very primitive, very simple room that people live in when they are incarcerated. So that's where the word cell came from. All right. Well, people were kind of like, oh, man, this is really cool looking. And people started picking up the hobby of looking at microscopes. And this guy right here named Anton van Leeuwenhoek, who's kind of strange looking as well, he was not a scientist. He sold cloth for a living. And when people would come to his store to get cloth, to buy cloth, he would say, hey, I'll give you a discount if you'll let me scrape things off of your teeth and look at it under the microscope. And I'm sure people looked at him kind of funny, like, man, you're weird. But some people did let him do it. And he would scrape people's teeth. And when he would scrape their teeth, he would take what he would collect and he would look at it under the microscope, and he discovered these things right here. Now, not these that are up here at the top. These are things that you'll see when you in pond water, in river water, and lake water, water that is rainwater that's been standing for several days. You'll find these kinds of things in there. But when he scraped people's teeth, he discovered this stuff right here. And what he discovered was bacteria and plaque, for lack of a better word. And this is what puts holes in your teeth. And so Anton van Leeuwenhoek, he's the one that discovered exactly what is it that creates these holes in our teeth is single-celled organisms called bacteria. And once again, here's what they look like. Well, a few years later came this guy, and this right here, his name is Matthias Schleiden. And he is the very first word that you're needing to write down a definition for. So since I don't have the textbook here to show it to you, I'm going to be nice and I'm going to type it here for you. And number one, Matthias, capital Schleiden. All right. And what he did was, let me make this a little bit bigger so that you folks that are, I forgot. Wait a minute. There we go. Let's make this a 14. There, that's a little bit bigger. All right. Schleiden, and this is the definition that you need to write down. Schleiden was a German scientist, and he used a new microscope to look at plant cells. Basically, what Matthias Schleiden did was he took the microscope, which was new at the time, and he started studying plant cells. And when he would study plant cells, he noticed that it didn't matter what type of plant that you looked at, grass or a big oak tree or any kind of plant. He noticed that their cells had all plant cells have similarities to them. And he thought that was very interesting. Every plant cell has certain things in it that it is just like all the other plant cells, like their boxy appearance, and that they're green because they've got chloroplast in them. They have big vacuoles in them. Those were things that he discovered. All right. Well, the second guy that we're going to talk about, this guy's name is Theodor Schwann. So, number 2, Theodore. Am I spelling his name correctly? Theodore. Does it not? Oh, yep. Take off the. All right. Theodore Schwann. All right. Theodor Schwann. Once again, German scientist. Now, what did he do? Well, he used the microscope. Ooh, that's not how you spell microscope. SCO. He used the microscope to study animal cells. Okay, so he used the microscope to study animal cells, and what he discovered was it didn't matter if you were looking at a little bitty mouse or if you were looking at a gigantic giraffe. They also had cells that had similarities to them, such as animal cells are round. Animal cells have many vacuoles inside of them. There's many similarities that all animal cells have. So that was what he discovered. Well, the two of them got together and they discovered that even plant cells and animal cells share things that are alike in both cells. And they found that very interesting, that people at the time thought that plants and animals had nothing in common. They were wrong, because the cells had things that were definitely in common. All right. So, number 3, time went by about 20 years, and this man, Rudolf, Rudolf, and his name is pronounced Virchow. Now, down here in the South, we want to say Virchow, but that's not correct. His name is Virchow. And he basically came up with a very interesting observation. He was a German doctor, and he proposed that all cells come from pre-existing cells, or cells that already exist. All right, so I didn't say pause for the other ones, but you're probably going to want to pause this and type it in. All right, so you hit pause. All right, so here's Schleiden. He's the one that studied plants. Here's Schwann. He's the one that studied animal cells. Here is Rudolf Virchow, and he's the doctor. And what he basically said, he came up with the idea that cells come from cells. And this was huge during this time period, because lots of people believed in something that was called spontaneous generation. And spontaneous generation is when something that is non-living can give birth to something that is living. Some examples I gave in class today: if you're a farmer and you're standing out by your grain pit and mice come running out of it. Back during this time period, people would say, "Oh, look, the grain gave birth to mice." Well, we know that the grain didn't give birth to mice, but they would see that 300 years ago and they would think, "Oh, the grain is giving birth to mice." And if we were walking by the road and there was a mud puddle and a frog jumped out of the mud puddle, back then they would say, "Oh, look, mud puddle has given birth to a frog." And people believed in silly stuff like that back then. Well, to us, it's silly today, but 300 years ago, it had to be discovered. And sure enough, living things have to come from living things. They don't just come out of a mud puddle. There's a reason why a piece of grass grows out of a crack on a sidewalk. The sidewalk did not give birth to that piece of grass. Seed fell in the crack somewhere, and it allowed for the grass to grow up and through it. So, Schleiden, him; Schwann, him; and Virchow, the things that they discovered was piled into one new theory. And this new theory is number 4, which is already written there, the cell theory. All right, what is the cell theory? There's 3 parts to it. Number 1 states that all living things are made of one or more cells. The second part of the cell theory states that the cell is the smallest unit of life, and all that's it. The number 2, the cell is the smallest unit of life, period. Yep. And number 3, all right, the third part here of the cell theory. All new cells come from pre-existing cells. Ooh. All right, so hit pause, type this, and I'll explain it. All right, so you hit pause. All right, so what is this talking about? Okay, well, let's break it down into 3 parts. The cell theory states that all living things are made from 1 or more cells. There's not a living thing on earth that we know of that is living that is not made of cells. Every living creature on earth, plant, animal, protist, bacteria, monitoring, all of them, everything is made of cells. There's not one thing on earth that is alive that we know of that is not made of cells. Everything is made of cells. Number 2, the cell is the smallest unit of life. If we look at your skin, we'll find cells. Those are the smallest living things that make up living things. You don't find anything smaller that is living. Basically, the cells are the building blocks of life. And number 3, all new cells come from pre-existing cells, what we just talked about. Spontaneous generation is a bunch of baloney. When you open your closet and a moth flies out, the closet didn't just give birth to that moth. We know that moths come from moths. So if you see a cell, then it had to come from another cell. Cells just don't fall out of the sky. So that is what the cell theory is. All right. Well, scientists then started wondering, well, I wonder what's inside of cells. And so they started making better and better and better and better microscopes. And they started seeing things like this right here. This right here is an animal cell. And if you look inside of it, you're going to see there's all this stuff inside of it. Well, they were like, what's inside? What is this? Well, what they started discovering was that the inside of the cell is made up of carbohydrates and proteins and waxes and fats and things like that, lipids. And basically what's going on inside the cell is made up of stuff that you eat, which we've already studied. Carbohydrates, proteins, lipids, things like that, waxes. And so what they discovered was that these things on the inside of the cell is made up of something that are called, number 5. Well, I keep doing that. Macromolecules. All right. And what is macromolecules? Macromolecules form by joining many small molecules together. Macromolecules come from a bunch of molecules. You could call them micromolecules, but they're just molecules. Comes from the joining together of a bunch of molecules. And when all these things are joined together, it makes these parts that you see inside this animal cell right here. All right, so I like looking at these different pictures of things inside the inside of cells. All right, so and as they kept looking, they started noticing this jelly-like fluid inside of the cell, and they realized, hey, we've already studied this. This is cytoplasm. And they were wondering, well, what makes up cytoplasm? And as they studied it, they started figuring out that it is made of water. The number one ingredient in us cells is water. Water is what makes up 70% of us. That's why it's so important that we have water every day. This tea right here that I'm drinking. Mainly made up of water. And that's where how our bodies get water. And that water goes to our cells, and that's how our cells use that water to help keep us alive. How does it do that? Homeostasis. The water is used to insulate our cells, and it helps to maintain a body temperature. That's why if it's a cold day and you run out to your mailbox to get the mail out of it, That's why you're not going to die. And you might catch a cold, but you're not going to die from it. Most likely, you're going to be fine. But if you throw a snake out into the cold weather, it's going to die because its homeostasis can't support it. Us humans, our homeostasis are extremely advanced, and so it helps to keep us alive, maintain a body temperature of 98.6 degrees. And another thing, that once things get inside this cell right here, water has to be inside the cell to help break it down, such as food particles. In order for the food particles to get into to be broken down and made into energy, it's got to be broken down. Well, the cell the cell water is what breaks it down. And if you'll think about it, we use water all the time to break things down. Why do you think we use water to wash a car? Why do we use water to wash dishes and clothes? It's because water helps to break down things, dirt, grease, things that it uses water can break things up and help wash them away. Another good example is at night when you're washing off your plate after supper. If something gets crusty on your plate and you can't scrape it off, well, we all know if you let it sit in water for a little bit, most likely it will break up. And the reason why it will break up and wash off the plate is because water is made up of two areas. It's made up of a positive area and a negative area. The positive area in the water molecule pulls on negative stuff, and the negative area of the water molecule pulls on the positive side of stuff. And so since you get this constant pulling effect, water helps to pull things apart and dissolve it. And that's why it's good inside of our cells. That's why we've got to have water. That's why water breaks things up on your plate and on your vehicle. So that's the importance of water. Well, all right. Well, that's basically everything that we have gone through today. I'm going to show you this right here so that you can pause it right now if you need to get these things copied down. And that is it for today. I hope you have a wonderful day, and I will see y'all not at school, but I will see y'all on the internet once again tomorrow. Y'all have a great day.